For the science experiment today, we're going to be looking at golf balls. Do they bounce more if they've been frozen or if they've been heated? And that's what our experiment is today. When I thought of this experiment, I had to think of my own hypothesis. What did I think? Did I think it was going to be, they're going to bounce more if they were heated up or if they were frozen? And what was the effect on that? We'll go over my answer at the end and everything, but what is the effect of the number of bounces after a golf ball is either heated up, and when I say heated up, it was put in boiling water for 10 minutes, or after being stuck in a freezer for 2 hours, what's going to be the effect of it? And I had 10 golf balls, which thankfully these were all golf balls that landed in my yard, so it didn't cost me a thing, which is always a good thing. Free golf balls are the good golf balls to use. And so what I thought for that is I think that golf balls that were heated up would have bounced more times than the golf balls that were frozen, because in my initial thinking was golf balls in the freezer, it's going to be cold, it's going to be frozen. When I bounced it, I was thinking it was going to weigh more, so it wouldn't bounce as many times. Or if the golf ball that was heated, it would have more bounce in it, I guess you can say. I guess we'll find out after the experiment which was correct off my experiment here. So this experiment is about the change of temperatures with the golf balls and how it affects the number of bounces, like I was just saying before. Are they going to bounce more if they were stuck in a freezer for 2 hours? Are they going to bounce more after being stuck in a pan of boiling hot water for 10 minutes? And so that's what this experiment is going to find out for us. Our key vocab words, as you see, be temperature, which is how hot or how cold the golf ball was. The bounce is moving up and down. Then golf ball, we all know what a golf ball is. And it's a small hard ball used to hit with a golf club. And it's made with some sort of usually rubber inside the golf ball to help with its bouncing ability. And then the other thing is the height. The ball when it bounces up and down. And so those are the key vocab words I could think of for this experiment that I had to come up with. I mean, some experiments will have more vocabs, with this one being a pretty simple one. Didn't have too many vocab words. So again, this concept is to determine when the density of a golf ball changes because of its temperature. Will it change the golf ball's ability to bounce? So with it being hot or being cold, will it change the bouncing ability of it? In our variables, the manipulative is the change of temperature, because that's what I'm changing, is the temperature. Extreme hot, extreme cold. That's going to be that variable. The responding variable is the amount of times that the golf ball bounces, and that's what I'm testing. How many times is it going to bounce? And the constant would be the type of ground that the golf balls were bounced off of. For this experiment, which you'll see later in the pictures, is I was just inside my garage. The garage door was open, and I used that for my testing because it wasn't going to change. Where if I was outside, you might have had the possibility of wind or other things affecting it. So I'm like, you know what? Inside my garage was probably the best way to do it. Here we go. And now my materials. I had 10 golf balls, which I was showing here. Yes, some of them have letters on them. That's because they belonged to someone before they hit it wide and they landed in my yard. My freezer, obviously, to freeze them for the 2 hours. My stove to warm up the pot. I had 4 cups of water I put in the pot. It took roughly about 5 or so minutes for the water to get to boiling, and then even after it started boiling, I let it boil a little bit longer before I actually put the golf balls in. I had the temp of the stove on high. Now obviously my garage, where I was doing the actual experiment, my laptop to put my notes into the measuring tape. And that's more or less just to help me to see if it bounced or if it was rolling. And now the procedure. So like I was saying before, I had the 10 golf balls. I put in the freezer for 2 hours. I put 4 cups of water into the pot, turned the stove on. After the water started to boil, I put the 10 golf balls into the boiling water for 10 minutes. After that was done, after the 2 hours with the freezer, I took the 10 golf balls out of the freezer, I went into the garage and I started my experiment. And then, and it was measuring tape helped with the 3 feet, so I knew it wasn't 4 feet one time, 2 feet every time. I want to have that constant height that I was dropping it above the 3 feet. So that helped out with that too. And then my laptop, I added my data with the number of bounces and everything. And after I got done with the freezer one, I went ahead, took that was about 10 minutes, took the 10 golf balls out of the boiling hot water, did the same thing, brought them into my garage, 3 feet, and let them bounce. After I was done with both the freezer and the boiling hot water, this is the data that I collected and everything. So I had the 10 attempts with each of them. And so freezer for 2 hours. The first ball had 12 bounces, second ball 13, third, fourth, so you can kind of see there. So there's a total of 123 bounces between the 10 golf balls for the freezer, with the ones in the freezer for 2 hours. So it averaged about 12.3 bounces each time. Then when I did the boiling hot water, it was less, as you can see the number of bounces. And this is me. It was either me just as I dropped it, or as I was looking ready to drop there. You can see I'm measuring 3 feet there. And here's the ball actually bouncing midair, going from the 3 feet and going down to the garage floor there. But with the boiling, it only averaged 8.4 bounces a time. And we'll get into that later. And here we go. This is more data that I collected with it. So for the freezer for 2 hours, the median was 12.5. The mode was 12 and 13. Mode is what was the number of bounces that were the greatest. So it was 12 and 13. And it was a range of 4. So it ranged from a high of this to a low of that. And going back there to the freezer, you can see the high of 14 to a low of 10. And so that's how we came up with the range between 14 and 10. Same thing with the boiling water. The median was 8.5, so basically an average of 8.5 for the mode. Most of them are either 8 or 9 bounces, and the range was 4, which would have been between 10 and 6, and that's how I came up with that mode, the range there. So both the ranges were the same. And then here's just a graph of the number of bounces. Again, freezer with an average of 12.5, and then the boiling water, average of 8.5 with that one. And again, here's my results. So the average number of bounces for the golf balls in the freezer was 12 and a half, which we saw in the graph before. The average number of bounces for the golf balls that were in the boiling water was only 8 and a half, which we saw in the data before. And the range for both of the freezer and the boiling water for the golf balls was 4, which we saw in the data before. And here's my conclusion. A golf ball is only a golf ball, or so people think, regardless of the temperature of the ball. My initial hypothesis was wrong. So I initially thought the golf ball in the hot water, the boiling water, would have done more bouncing than the one in the freezer, because I was thinking the freezer, the ball was going to be more dense, and when it hit, it wouldn't bounce as much. I was wrong. With the facts that I obtained, the actual difference was actually inside the golf ball. And I didn't realize that until I was actually taking the golf balls out of the boiling hot water. As I was taking them out of the hot water, for an example, yes, they're both golf balls, but I noticed as I was picking them up and almost like squeezing them, some of them weren't their normal hardness. They were kind of soft and had more flexibility. And as I was going into the garage, I'm like, okay. I didn't think anything of it, but after I did the test, I noticed, wow, there's a lot less bounce. I'm like, okay, what was the reason for that? And it came back to me because when I was squeezing it, there was more flexibility, so when it bounced, it wasn't that hard bounce anymore. It was kind of like a flat bounce, so it didn't have the ability to bounce as many times as the golf balls that were in the freezer. So my initial hypothesis was incorrect. That it was actually the balls that were in the freezer that had the more bounces, were the ones in the boiling hot water. They just didn't get that I guess you can say, to bounce as many times. So, but that's why scientists do tests and everything, just to figure it out. I mean, what if, and this was a good what if for me. And so the real world application is this experiment would help all golf ball makers. People can't control the weather, but the manufacturers might be able to come up with a ball that is more durable to the weather, meaning extreme cold or extreme heat. Obviously here in Florida, we do get extreme heat, near like Arizona and other places where maybe they can make a ball where the rubber's more durable for those hot temps and everything. And last one here, and this is just my diary of when I got certain things. And so, like I said, all these golf balls were nicely donated by golfers that went into Out of Bounds, which happened to be my backyard. And so I was thankful for that, to have any out-of-pocket expenses for this experiment. And so this is my experiment on golf balls. Are they going to bounce better after extreme heat, meaning being boiled for 10 minutes, or extreme cold, meaning in the freezer for 2 hours? And so that was my experiment.